Hello everyone, so in this video we'll be discussing hyperbola. This is still part of the conic section that we have previously discussed. So for now, we'll start discussing what is hyperbola and how does it differ with parabola, circle, and ellipse. So basically, in geometric definition, it relies on a cone and a plane intersecting it. So as you can see, we have cones here. And if there's a plane that intersects cone, as you can see, it would have a shape of the hyperbola, one here at the top and one at the bottom. Also, we can also rotate this. We can also have hyperbola at the right or hyperbola at the left. So in algebraic definition, this is a set of points in the plane such that the difference of the distances from two fixed points called foci remains constant. So in the ellipse, the sum of the distances from two fixed points called foci remains constant. Here in hyperbola, the difference from the two fixed points called foci remains constant. So that's one of the difference between hyperbola and ellipse. So given here, as you can see, we have hyperbola that is opening from the left and the right. So we have also two focus, which are what we call the foci. We have the foci 1 and foci 2, or focus 1 and focus 2. And it says that from each point in the plane, the difference of the distances to the foci is constant. So that being said, we have this formula from point A. We have d sub 1 minus d sub 2 is equivalent to a constant. The same goes with point B. We have d sub 1 minus d sub 2 is equivalent to a constant. So basically, the difference between the points from a plane is just a constant. So getting to know the parts of our hyperbola, we have the center. This green point here is what we call the center. We have the transverse axis. The transverse axis is the longest axis in the hyperbola. And we also have the conjugate axis, which is the shorter axis in the hyperbola. And you have to note that the axis here is not only written until 2. Meaning to say, you cannot go through much in our Cartesian plane. There's a point that we are also considering in drawing the axis, the transverse axis and the conjugate axis. And the points or the endpoints of the transverse axis are what we call the vertex. So we have here the point of the transverse axis are the vertex of our hyperbola. We also have the foci. So we have here the foci, and of course that is inside the curve of our hyperbola. So this is now the hyperbola equation. So we have x minus h squared all over a squared minus y minus k squared all over b squared is equal to 1. Or we can also have that y minus k squared all over b squared minus x minus h squared all over a squared is equivalent to 1. And the difference, what makes hyperbola different from the parabola? And again, in parabola, only one of the variable are squared, while in hyperbola, as you can see, both of the variable are squared and we have the denominator. And what makes the hyperbola different from the ellipse is that though their equation looks the same, however, you have to note in ellipse, this is addition, but in hyperbola, this is subtraction. Okay, so you have to note that hyperbola is subtraction, ellipse is addition. So the center still in hyperbola is at hk. So in order for us to locate the center, that is in HK. So the length of the horizontal axis is 2A, length of the vertical axis is 2B, the same with the ellipse. We can determine if the hyperbola is opening vertically or horizontally. If x is first, hyperbola is horizontal, meaning to say, if x is written first, or the equation for the x is written first, hyperbola is horizontal. However, if y is written first, just like here, hyperbola is vertical, meaning to say we have opening up and down. But if it's horizontal, it's opening left and right. We also need to use the formula c squared is equivalent to a squared plus b squared. In ellipse, we'll be using c squared, and we have to determine which has the larger value, a or b, and then we'll be subtracting. Here in hyperbola, we'll be adding the value for a squared and the b squared. So that is how we locate the foci. So here in hyperbola, we also have the equation of asymptote. So the equation of each asymptote can be found by using the point-slope formula. We can use the center as the point, and slope can be found by counting on the graph from the point to the corner of the rectangle. Or easily, we can just use these formulas here. If we have a transverse, if the horizontal is the transverse axis, we'll be using these formulas. It's y is equivalent to k plus b over a. So you have to note this part. If it's horizontal transverse axis, b is at the top or at the numerator, and a is at the denominator. And the second one is, this is just subtraction. So we have two equations of the transverse axis or the asymptote. We have k plus and k minus. If it's vertical transverse axis, our numerator is a, our denominator is b. That's just the only difference here in finding for the equation of the asymptote. So these are the procedure in graphing hyperbola. So first, we have to put it in standard form. Determine if the hyperbola is opening vertically or horizontally. Identify the center. Identify the endpoints of the horizontal axis. Identify the endpoints of the vertical axis. Draw a rectangle. Sketch the asymptotes of the hyperbola. Draw each branch of the hyperbola and be sure to go through the vertex of each, the endpoint of the transverse axis, and approach the asymptotes. And then we can already locate the foci, and we can already find the equations of the asymptotes. So in graphing hyperbola, there's much consideration when graphing ellipse. So as you can see, we have 10 steps here in graphing hyperbola compared with the 6 steps in graphing ellipse. So let's try to answer some example. So we have here graph y squared all over 64 minus x squared over 36 is equivalent to 1. So this is already in standard form. So there's no need for us to change this or put this in standard form. So now, since our graph, or since our equation, as you can see, is the first determining factor if it's opening vertically or if our hyperbola is vertical or vertical transverse axis or horizontal, is the placement of our y and x variables. So here, as you can see, since y is written first in the equation, meaning to say our hyperbola is in vertical transverse axis. So meaning to say it's in vertical. So that being said, following our procedure here, we have already put it in standard form. We've already determined that this is vertically. the hyperbola is opening vertically. And the third one is we have to identify the center. So from here, as you can see, we don't have value for k and h. So meaning to say the center is at 0 and 0. So if we try to graph that one in a Cartesian plane, let's just try here. So that is, our center is at the origin. And then afterwards, after we have located our center, the next step is we have to identify the endpoints of the horizontal axis. So how can we determine the endpoints of the horizontal axis? So in order for us to determine the endpoints of the horizontal axis, we'll be basing on the value of our a squared and b squared. So for the horizontal, that is for a. So we have to find the value of a. So that's a squared is equivalent to 36. And square root both sides. So square root of 36. So our a now is positive negative 6. So that is how we locate for our horizontal axis. So the same goes with the vertical axis. We have b squared is equivalent to 64. And the square of 64, as we know, that is equivalent to 8. Positive and negative 8. So after that, we'll try to locate that in our Cartesian plane. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is now our limit. And since this is vertically, or our hyperbola is opening vertically, and again, the limit is the transverse axis. So y is hyperbola, and again from here, the length or the endpoint of our vertical line or the axis is the endpoint or is the vertex of our vertices of our hyperbola. So since it's opening up and down, or opening at the top and the bottom, so meaning to say this one here is our vertex and this one here is our vertex as well. So that is the endpoint of our hyperbola that is opening up and down. So after that, we've already identified the endpoints of the horizontal, identify the endpoints of the vertical. Now we have to draw a rectangle out from the endpoints. So let's try to draw a rectangle out of here. And then this is how we determine our asymptote. Okay, so that is how we determine our asymptote. I'm just making this a broken line. So we've already created a rectangle. Sketch the asymptote of the hyperbola. In sketching the asymptote of the hyperbola, we have to pass through the center endpoint here, the center and here. So that would form like an X. So this is now our asymptote. And of course, that would extend. So we have also here our asymptote. These are now our asymptote. So next one, we have to draw each branch of the hyperbola. Be sure to go through the vertex of each and approach the asymptotes. So that is our limit. So we have to approach the asymptotes. That is, the asymptotes is the limit of our hyperbola in which we have to reach. So since this is our vertex, so we have to approach the the asymptote. So our hyperbola would somehow look like this. And of course, it's extending. And this is our vertex. We have to make sure that we are also touching our vertex going through our asymptote. So this is now what our hyperbola looks like. So these are our hyperbola, this one as well. And the x arrow lines are our asymptotes. So after we have drawn branch of the hyperbola, we can already locate our foci. So again, in locating the foci, we'll be using this equation. The c squared is equivalent to a squared plus b squared. So as we know, our a squared is 36, our b squared is 64. So c squared is equivalent to 36 plus 64. Square root of that, square root both sides. So c is equivalent to square root of 36 plus 64, which is just equivalent to positive negative 10. So meaning to say, our foci from the center, we have to count 10 going up and 10 going down. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9. We have the 10. So meaning to say, this one here is our foci. This is our foci 2. And then we also have to count 10 from the center. So this is also our foci 1. Okay, so that is now our foci. So if we would try to find the coordinate of our foci, we have 0 and positive 10. We also have 0 and negative 10. So these are our foci. Now, after we have located the foci, we have to find the equation of the asymptotes. So how can we find the equation of the asymptotes? So again, we have to use this formula, and since the transverse axis is vertical, again class, transverse axis is the longest axis in our hyperbola, and since the vertical is the longest here, meaning to say we'll be using the vertical transverse axis. So as you can see, we'll be using this formula and this one as well. So we have y is equivalent to k plus a over b times x minus h. And we also have y is equivalent to k minus a over b times x minus h. So our k is 0. So as you can see, we don't have value for k and h. So that's 0. Our a is 6. Our b is 8. X is, we have the x. H is 0. So meaning to say 6 over 8, or that is also equivalent to 3/4 x. The same goes here. We have 0 minus 6 over 8 times x minus 0. So we have negative 3/4 x. So these are now the equations of our asymptotes. Okay, so these are the equation of our asymptotes. So basically, that's it in graphing hyperbola and determining the parts of the hyperbola. So again, these are our asymptotes. This is the transverse axis. We also have the conjugate axis or the horizontal axis. And we have the foci here. We have the vertex in here. And we have the hyperbola. Okay, so I hope this example is clear. Now let's move on to another Example, so we have here graph x minus 3 squared all over 36 minus y plus 2 squared over 16 is equivalent to 1. So in this case, this is already in standard form. So what we have to do is to find the center. So the center here is 3 and negative 2. So let's try to graph that one. So it should be we have 1, 2, 3, 1, 2. So this is our center here. So that is our center. Next one is we have to know if our hyperbola is vertical or horizontal. So since our equation, the x is written first, so meaning to say it is horizontal. So that is our hyperbola. It's opening to the left and to the right. So next one, next step is we have to find our a and b. So our a from the equation is a squared is equivalent to 36, and the a, or the square root of 36 again, is equivalent to positive negative 6. And for the b, we also have b squared is equivalent to 16, and square root of 16 is equivalent to positive and negative 4. So we'll be counting again 6 units left and right. So we have 1, 2, 3, 4, 5, 6. So this one is the endpoint. 1, 2, 3, 4, 5, 6. This is another end, or this is the vertex of our hyperbola. And next one is 4 up and down. We have 1, 2, 3, 4. So this one here. We also have 1, 2, 3, 4. So this one here. Now we will be drawing a rectangle out of that. So assuming it is running through the correct points. And as you can see, again, our transverse axis is horizontal. Our transverse axis is horizontal. And we have to create our asymptote. We have to draw our asymptote. And it's passing through the center. And then we also have here the asymptote on this side, passing through the center, assuming it is a straight line. So that is our asymptotes. And again, this is our vertex, so meaning to say our parabola is extending until here, going here, and going to our asymptote. So the same goes here on this side. So we have vertex going to the asymptote. So these are now our hyperbola. Next one is we have to locate the foci. So in locating the foci, that is a squared plus b squared, wherein a squared is 36 plus 16. Square root of that, we have square root of 36 plus 16, that is equivalent to 2. Positive negative 2 square root of 13, or approximately equivalent to 7.2. So from here, from the center, we'll be counting 7.2 to the right and 7.2 to the left. So we have 1, 2, 3, 4, 5, 6, 7. And then let's say it's here. The point 2 is here. So the foci is in here. So we also have 1, 2, 3, 4, 5, 6, 7, and then 0.2 is possibly here. So these are our foci. So next one is we have to find the equation of our asymptote. So since this is horizontal transverse axis, we'll be using y is equivalent to k plus b over a times x minus h. The other one is y is equivalent to k minus b over a times x minus h. So y is equivalent to k. Our k is 2, or our k is -2, plus our b is 4 all over our a, which is 6, times our x minus our h is 3. Same here, y is equivalent to -2 minus 4 over 6, x we have minus 3. So basically, this is -2 plus 4 over 6, that is, for simplify the 4 over 6, that is 2/3. 2/3 of x. 4 over 6 times -3, that is equivalent to -2. Or -2 minus -2, that is equivalent to, -2 plus -2, that is equivalent to -4 plus 2/3 of x. So this is now one of the equation of our asymptote. The other one is -2 minus 2/3 of x plus 2. So cancel the -2 and 2. So that is -2/3 of x. So we have this as our another equation of asymptote. Okay, so the last example, we have write the equation in standard form and graph y squared minus 4x squared is equal to 64. So this is not in the standard equation, so we have to change that into standard equation. And as we know, this is always equal to 1, so meaning to say we have to divide by 64 both sides. So we have y squared is over 64 minus 4 over 64, that is 1 over 16. So our denominator is 16 and we have the 1. So as you can see, y is written first, meaning to say our hyperbola is vertical, right? And then our center is at 0 and 0 because we don't have value for y. We don't have value for h and k. Then afterwards, let's try to graph it first. Assuming it's a straight line. So we have to find our a and our b. So a here is square root of 16 is positive -4. The b, square root of 64 is positive -8, right? So after that, we have to locate it here in our graph. So we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this, we have to draw a rectangle. And then after we draw the rectangle, we have to draw the asymptote. So asymptote here. We also have one in here. Then, as we know, this is the vertex. So meaning to say our hyperbola is somehow like this, going through the asymptote and the vertex. So that is, and then afterwards we have to find our foci. So foci is equivalent to a squared plus b squared. So that is c square root of 16 plus 64. So square root of 16 plus 64, that is equivalent to 4 square root of 5. Positive, negative 4 square root of 5, or approximately equivalent to 8.9. So we have this 8 here and then 9 here. So practically our foci is just around 9. So our foci is around here as well. Okay, so that is our foci. Next one is to find the asymptote. Y is equivalent to k plus, this is a over b, x minus h. The other one is y is equivalent to k plus, minus a over b times x minus h. And since our k and h are 0, so meaning to say our a is 4 and our b is 8, so that is 1/2 x. This is also negative 1/2 x. So these are now the equation of our asymptotes. So I hope this lecture or this discussion is clear with all of you. So that's it for our discussion for this afternoon or for this video. Thank you everyone, and bye-bye.